Okay. Indexings are mainly used to okay uh, increase the performance of an SQL. So whenever you wanted to read a particular topic, so we should avoid the full table scan. Full table scans FTS. Full table scan. What is the meaning of FTS? Reading or scanning complete table for particular information. Is very important. They will ask particular information is a full table scan. Example, I wanted to find student Vinay. So if you do not index name Vinay, you are going to look for every record till you find that record. You are going to look for every record of the table. That is called full table scan. So this is like reading a full book without using the index pages to find a particular topic. So to better off reading or avoiding your expensive operation, you are indexed your topics such that you read the index pages. Okay. But imagine there is a big table. Okay, index. Okay, I'll recap quickly. What is the index concern? Example, we have an employee name, department number, and the salary, and of course you have an employee number. So please remember, primary keys are auto indexed. You need not to create a primary keys index for the primary keys because they are auto indexed itself. Okay. Example, we have probably have a thousands of employees. Okay. Okay, we have thousands of employees. You wanted to find a particular name. Instead of reading all the columns, sorry, all the rows of the record, we can index. How index happens here? Example, e-name. If we index, I'll have a row ID. Row ID example here, row number. Example 4 is my row ID. Whenever here, you'll not get much benefit of it because here the values are very distinct. Okay, index is also as big as your book. Example, this is not repeating. This your pages is also not repeating. But anyway, example, you have a multiple Vinay in your table. Okay, what happened? It is going to have all the address of that person. This person is address at 4 and address at 6. It has all the information. So this is how the index has been saved along with the column values, that column that is being indexed along with an address of a records. Okay, this is we saved. Okay, you wanted to see the address of a record, quickly hold on. I was telling don't watch this man. Okay, livesql.com. I'll show how the row IDs looks like quickly. Every record has unique row ID. Okay, what is row ID, guys? You know that, anyone? Enoch, you know what is row ID? Row number and row IDs.
Row ID represents address of a record inside the table.
Okay. Anyone else? Other people knows what is row ID looks like? Nobody knows.
Sir, row ID is a unique number which can be starts from the 1 to some extra numbers.
That the row number, not row ID. See here, row ID, comma, ID from test. Row ID is your pseudo column. It has actually 16-digit hexadecimal number. You cannot understand yourself what is this. It represents some information like your postal address, where this record exactly locating within your database. This is a 16-digit, 4 plus 4 plus 4. 16 digits are there. There is a concept I think you will not understand. Even I explained, you will not understand. It has an exactly where there is segments, blocks, rows and all. You have a table space, high level, like how your address home has been located, your area, followed by the street, followed by cross or whatever is. You have an area, then you have a street, then a cross, main roads and all like that. Database is logically separated with multiple elements. We call them table space, segments. This is a DBS concepts. blocks and the rows. This is how the record has been located. This represents exactly each one 4 represents what is the table space. See, each last one is different. Look at here. Even though everything is same, 3 FAAA, FAAB. Hold on a minute. 1 minute. Hello. Sorry. So look at here, even though every record, sorry, every record in your database has a row ID. Row ID represents, just for your information, this is something I'm diverting my topic, but yeah, to connect it, how the row ID looks like. See, this is your database, correct? Database is a big space. In that, we are going to separate, example, we are going to storage, we call our database. We have different files. Like this is take an example of your C drive. Okay, C drive. The database is like your C drive. In that I can have a multiple folders, correct? Like this database is a big one. I can have a data files. We call DF1. Data files is the files being attached to. This is the storage files attached to the database. Okay. Data file 3. Okay. We have 3 different data files. Each data files is again logically separated by table spaces. How we are why we are maintaining is easy of our maintenance. We do create table spaces. Table spaces. Each table space is again having segment. We call them a segment. Again, logical separation. We call them a segment. Each segment can have multiple blocks. It can have a your data is exactly goes sits in a block. It is going to sit in your block. This is how database storage has been maintained, but it's none of your business. But to understand what is a row ID, each one represents what is in data file, what is your table space, what is your segment, what is your block. That's where it is been sitting in your data. So it having this full address, it is having this example. This represents this block. Okay. So whenever we are using the row ID, I am not going to read entire of the database because row IDs exactly locate your logical address of a record within the database, just like your postal address. The postal address has so much information such as your area code city, area code, street number, door number, correct? That's how easily we can locate. If one of information is missing, you are need to search a lot of your area. Example, simply a door number is missing in that particular road. I need to search for everybody for that particular information. That is how these row IDs, when I indexed ID 1, if I create an index on the create an index, any index, I can just specify ID on test of ID. So what happened is along with an address of the records, along with the column values, the index will be saved like this. So example, one could be in multiple places. Example, I have a 1, it could be in multiple places. Okay, look at here now, I have created an index. Sorry, I created a record, but one value is repeating in the multiple places. Even the value is repeating, the row ID never repeating, because it is going to be stored in individual blocks at any time. So because see now when I index this particular column 1, along with the column 1, all the row IDs will be stored within the database. What happened in this case? The column value is 1. What is the row ID? This is row ID. All the row IDs will be saved for along with the column 1. Example, all these values will be saved. So whenever I wanted to read a data, I will not look for the table. I go and look at and find the row IDs and going to locate my record within the database. That is how index are usually helpful. Please understand, row IDs are not like 1, 2, 3, 4. It is a 16-digit hexadecimal number, indicates where exactly the record located within the database. That is how indexes are helpful, making the search faster. Got it? Clear?
Yes.
Okay. Answer is all clear or not?
Clear,
Yes,
sir.
sir.
Yes,
Yes,
sir.
sir.
Yes, sir.
So now tell me what is an index? What is an index? Sagar, what is index?
Index is a pseudo table which is created to optimize the performance of the
Mm-hmm.
table,
Mm-hmm.
and yeah, it stores the address of the similar records which are similar to retrieve it faster.
Okay. So it shows it, so it saves the column values. It saves the column value. Which column values? Example, this is a column value on which index is being created along with the row IDs. Row IDs represents exactly the physical location or your logical location of your record within the data. See, this is, I need not see, this is big file. It is a 10 GB file, 10 GB file, 10 GB file. I need not to read all 30 GB. I just always goes here because it has every information where this location has to be found. Correct? So that's how indexes are helpful. Okay, this is enough as of now to understand how indexes are helpful. There is something called execution plan that I'm going to explain you, because for that I need to have my SQL developer tool. I just deleted. I don't know. I need to download. I'll download today. So I'll show you how indexes are helping out reading the data easily and how the plan looks like. Okay. So this topic I will going to cover it later. Any question about any of these topics we covered? Are you making a notes out of this, all these, please? Questions, what is a server or a node? Please, if not, I will share this record, this notes. Please, at least for each of them, write to two lines of your answer.
Yes.
Yes.
Yeah, that will help you for easy of, if even though you know the answer, you should explain it. Yes. Otherwise, okay. Disadvantage. Anyone knows what the disadvantages of indexes? Explain, extend. I told you this disadvantage indexes.
One disadvantage is that if the table is too big, then it may
Wait,
consume
Sagar.
lot
I
of
will
storage.
ask. I will ask someone. Okay, only is not class is only for
Sir,
one person.
DML process will be slow, will become slow.
Who is a Shilpa?
No, Pooja.
Puja. Okay. Can you explain one more time? His answer is correct. I just want to hear one more time. Yes. What is the disadvantage of indexes?
Yeah, because of the DML process, like the insert, delete, and update, we can't do that. So
No,
through,
whenever you do a DML operation, all the indexes has to be rebuilt. Or, say example, I am going to insert one more Vinay. Obviously, this index has to be updated, correct? And I'm
Yes.
going to delete this. This entry has to be removed from here. So every DML operation you perform on the table, all the indexes has to be manipulated. Example, every column I indexed. What happened? Example, I have a table of 8 columns. Every column I index. What happens? Every one record inserted into a table, all 8 indexes has to be updated, correct? Then it slow down your DML operation. Maybe your search operation increases, but it is slow down your DML operation, and also each one requires its own space. It is a also requires a space. Example, yesterday you saw that complete reference. The index itself is a 10 pages, correct? How the big indexes is depends on the how the big the table is. If the page of the book is 10,000, you may have an index page itself 10 pages. Correct? If book is 20,000 pages, then what happens? Your index itself 100 pages. Correct? Example, Bhagavad Gita or Mahabharata is a 20,000 pages book. Can you imagine how many indexes pages it can have? It is many.
Yeah, more than.
In this case, what happened? Your search again slowdowns, correct? Because finding a topic itself through the index, it takes to read it 100 pages. Is it efficient? Not efficient, na?
No, sir.
Okay. So yesterday we're talking about call data records. Call data records. Example, you have a telecom data. It has a call data records. ID, call ID. Okay. Customer number who's calling it. And destination where customer ID and calling number. I just put the calling number, called number. Okay. Called number and call date when it is being done and the duration of the call. These are simple columns I could think of as of now. Okay. These are the few columns I can have in my table. What are the things we have, like call data, calling number, called number from which, from the number you called, that is your called number, like under duration of the call. Okay. This is your table. Imagine you have 1 crore subscribers. Okay. Each subscribers, each day call, daily call is, each one is doing 5 calls. Total call records, how many? Per day? 5 crores. What happens for 30 days? What happened for 30 days? 150 crores. What happened for 1 year? 150 into 12. 150 into 12, that is the number of records has been, correct as this number? 1,800 crores of records has been generating. Even average, we have daily 5 calls per day for 1 crore subscribers. This is your 1 year data. Okay, 1 year data. This is example Jan 2025. Okay, Jan 2025. Okay. So this is the volume of data you need to scan for particular record. Example, I wanted to read in this 150 data, 150 crores per month. This is January 2025, have 150 crores of record. Like that, February also have 150 crore records. In this case, can you imagine, guys, any type of index will help or not? Example, I wanted to see the total call duration for the January 2025. How many records you need to read? You have in front of you the numbers, guys.
150. 150 crores.
150 crores. Okay. So is it helpful using indexes in this case?
Yes.
Our guys are understanding or not? If you're not understanding, I'll omit this topic. It is not for you. I just leave it because I'm not getting any
Understanding,
answer.
sir.
At least say yes, no. I told you that.
Yes,
I'll
sir.
probably very specific people I will ask going forward. Okay. Then I will get it. Okay. So reading this kind of a book like indexes or data, index will not help because your index itself could be of several hundred pages. Then what is the best way to read the data out of this? So indexes are not helpful on two instances. When you are heavily indexed your table, it slow down your DML operation and it will not give the performance. Example, I want to, this customer has made 2 calls on January 25th, January month he had made 2 calls and also he made a few calls in March and he made few calls in April. To read 4 records, how many data I should read, scan I should do? Even though you are using an indexes, how
150
many
into
scales?
4.
Huh?
150 into 4.
No, we never know. We never know. You cannot stop it here. You may have data in December also. We never know. We cannot read consistent means you should read all the data to ensure that you read every data of the customer. One, inevitably you need to read these many records. Even though you use indexes, the index itself is so big because it has to maintain 1,800 crores of record within your index table also. Getting my point? Because even though you're indexed, how many indexes values will be there based on the how many distinct customer you have. How many distinct customers I have? 1 crore distinct customers I have. How many entries will be there in your index? How many entries will be there in your index?
150 crores.
1 crore. See, for every,
Oh.
I am going to index on this column. Krisha, tell me how many values will be there in index if I index on the customer ID when I have a customer base is of 1 crore.
1 crore.
1 crore, exactly. Because look at here, I am going to have the index values on the customer. Each distinct value will have, and it has its respective row IDs. Row IDs could be many. Based on the how many calls he made, those many row IDs will be correspondingly saved. But how many values are there in my index? My values are there in index itself 1 crore because my customers are 1 crore. Then what is the depth of your index? The depth of your index is 1 crore records. Reading such index is also not helpful because I wanted to find an information about a particular, you need to read a big index. That is also not give your performance benefit. Then what is we have to do? Then what we should do here, this is a concept called partitions we do. Example, your table could have a data randomly like this. Okay, it has a data. All your call data has been randomly put across your table. Okay, you have a Jan data. Okay, what we can do is we can logically separate your data into small partitions or a group of logical separation. It's not like you are not going to create a separate table. Whatever the data you have, you are logically separating, like just like your home. Your home is a big table. What you have done, you are not like dividing your home. You are logically separating, putting a small wall so that you differentiate. It is a kitchen, it is a dining, it is a bedroom, it is hall, it is a balcony. So example, I wanted to find all the items in the balcony. You do go and search out all your house? No, you go to balcony. From the balcony, you find your items. Same way, the partition is nothing but logical separation of the data within the table. I will explain you very well. Don't worry. Partition is nothing but logical separation of data within your table. Okay, let's understand how we can do. Instead of keeping all the items here and there, then what I'm going to do is this table, I wanted to read, example, I wanted to read all the data of the January data 2025. It could be here. You need to read entire table. Correct? Rather than what I'm going to do is, I'm going to logically separate my data and I'm keeping all the January data in one place. I'm going to keep all, whatever the data is coming, I'm going to keep it all my January data in one place, February data in another place, and March data is on another place. This is still the table is one. Call data is still the table is one, but I'm logically separating my data. Okay, that is called, each separation is called a partition. It's not like physical separation, it is a logical separation. You are dividing the data, still the data, your table is the same. Still your data is the, sorry, table is the same. Okay. But I wanted to read all the January data. Then I don't want to read all the partitions. Where is your data is residing? Your data is residing in a single partition. This is called logical separation of your data is called partition. What is an advantage? Without using an indexes, I can read the data very quickly. Example, even though I have how many crores of records I have per month, 150 crores record. All the data here, example, I need all the data of the January 2025. How many data I should read, scans I should do? I don't want to do 1800 scans because I have kept all my data in a logical manner, such a way that all January data will be in the partition 1. This is your partition 2, and this is your partition 3 and partition 4. Like that, I can create 12 partitions for 12-month data. Whenever I want a December month data, what should I do? How we are going to easily get a data? You go to the partition number 12. That is your December data. Example, I have a December data here, December 2025. So should I read? See, it is very easy. Yes, here I skip all these partitions. I'm going to read in a single place. From there, I'm able to get all the data. Correct? So this is very important concept being used in databases whenever tables are very huge. Example, I wanted to find total call duration of January. Why should I read all the, even though you create an index, you already understood what the disadvantage of creating an index in the last table. Your index table itself is very huge. We never know that the December data could be here, anywhere in your table. Even though you create your index, it is going to be very large, that does not efficiently fetch your data. In these cases, whatever the records you have, you are logically separating the data. That is called your partition. Okay. There are several partitions are there. You can also say list partition. List partition is like here. January partition 1, February partition 2, March partition 3, 4. So example, I need January month data. How many partitions you read? In fact, you read only 150 crores records and you are avoiding 1800 minus. This is the records you are going to avoid. You reduce so many. How many? 1650 crores of records you are going to avoid reading, because you know this. This is a simple example. If someone asks you, explain me concept of partition. It's very simple. I wanted to find a pen in my house. If I don't know where it is, you are going to read your complete house. What is it is scan called? What is it is called in the database operation?
Full table scan.
Full table
Full
scan.
table scan. It is very expensive in nature. Example, if you have a logical separation, I say it is in study table, study room 1 and table 1. You go to study room table and you find it pen on the table. This is how logically partitions are worked. Got it? That is how partitions are helping people to get the data very fast. So whenever you are reading the large amount of data, indexes will not help, because it is a two lookups. First is you need to go, example, they have been, customer ID has been, see, you cannot use partitions on the customer number 1 here, because this customer number could be here. Example, I wanted to read January month data. You know how many entries will be there for January month? Nikki, how many entries will be there for January month? If you create an index on this column, how many entries will be there for each of your key index keys? This is your index keys each, because I am creating the month of them call date. How many entries will be there for each of the month?
1.
Hmm?
1.
Huh? 1 is a month.
Based
How many
on
entries
number
will
of
be there for this? Row IDs will be
2.
storing for month.
Yeah.
How many? Simple mathematics, guys. You have answer in front of you.
31, like month based on.
Come on. I'm saving
150.
all the entries for January in my index. How many row IDs will be there? How many entries will be there for January? Anyone? See, what is the call duration for each month? What is the call numbers for each month?
150 here.
So God should save you all, really. Thoo. I keep telling from the beginning, this is the number of. See, I'm telling this is the call data for your January month. What is your call data records for each month? I written here now. Guys, what are you thinking? I told you that day, go and study maths first. Anyway, January is having 150 records to find any data within the January. How many data, how many index scan you should do? 150 crores time you need to go, find a row ID, come to the table, get the data. Go to the index, go to table, get the data. Go to index. This is called a lookup. What is lookup? Go to index, find the row ID, get the data. Go to index, find the row ID, get the data. Go to index, find the row ID, get. How many times you need to do this lookup for January data?
150.
150?
Crore.
150 crores time you have to do. Is it efficient? Not at all efficient, because you are at a time reading a two lookups, one for the index, finding the row ID, using the row ID, going to table and getting the data. It is using a two lookups. Whenever you're losing such a large amount of data, indexes are really not at all helpful. It is slow down your searches. Then what is the other way of reading the data? You see, one way of reading the indexes is to improve the performance. But here it is not helping you because your index itself is so big. 150 crores record, you need to look for indexes values, indexes row IDs. Then taking a row ID, go here, find it, taking the row ID, go and find it, taking the row ID, find it. It's deliberately slow down your performance. Then instead of indexing, we are going to concept called partitioning. Then here I want January data. I just go read everything from partition 1. I don't even care what is there in partition 2, 3, and I don't need indexes at all. Do I need indexes here? I don't need. I know that all my records are here. I know that's all my items. Example, I want to find all the kitchen items. Are you going to find it in bedroom? Or are you going to find it in the kitchen? You're going to find it in the kitchen. You don't care about what is there in other. You might be having a bungalow of 10 bedrooms. Why do you care? You know that you're organized the data in such a way that your items are present in a kitchen. You just go to the kitchen, you find your items. Why do you care about is it 100 bedroom bungalow or a 1000 bedroom bungalow? It doesn't care about it. The same way, when the indexes are very not helpful when you have large amount of data, you are logically separating your table, that is called partitions. Okay. So how partitions will help? It's logically organize the data. You are reorganize it. That is clustering concept. You have the same way here. You reorganize the data such a way that each partition contains certain data. This contains your January data, February data, March data, etc. etc. Got it? What is partition? Anyone let me explain me what is a partition with a simple knowledge, simple layman words.
Reorganizing the data in the manner of
Partition is a logical separation of data. Logical separation, not like physically or not dividing the table. It is a metadata. When you say partitions, create a partitions, it is going to manage the data in this manner. Got it? It is a logical separation of data within a table. Next, you said something, Avinash. Each partition contain certain specific information. Specific information. You can always use this call data as a reference. Example is reading call data for telecom records. Telecom call data. Reading 1 month data. 1 month data for telecom call data. Correct? Example, this is a very simple example. You can example, you have a 12 months data. Instead of finding the data and belongs to 12 months, example, take example, you have 1 crore subscriber, daily 5 calls. Total call records per day is 5 crores. In a month, 150 crores. Total is this. Example, you wanted to find all January month data. You need to scan 150,000 crores of index values if you created on the month column. Rather than that, we can logically separate the data so that each partition contains 1 month. Example, I want December. I don't even look all before data. Just I go here, read every data from the December and I find it. Got it?
Yes, sir.
Any question? Shilpa, any questions?
No, sir. Understood.
Okay. There are different type of partitions we have. List partition, range, and hash partition. Example. Okay, take an example of. Okay. We have 1,000 accounts. We have 1,000 accounts. Okay. Account number we have 1 to 1,000. 1 to 1,000 accounts we have. So each example, I can create a partition for each account number. Example, I am going to create partition example like a partition number 1. It contains all the data. Be a mute, please. That. Okay, this is a partition number. What it contains? It containing for the account number. You can say account number here. Account number. Account number. This partition contain all the data related. Partition 2. Partition 2 can contain the account number 2 like this. You can. Whenever I want this account number, example, this is your customer ID. Example, customer ID. Okay, take an example. So you can create the data partitions for the customer ID. Example you have here, correct? I can create all the data belongs to one customer. Well, can be created. Example, how many partitions I'm going to create in this manner? How many partitions? If I create a partitions based on the customer ID, how many partitions will be created?
1 crore.
Yapa, 1,000. Because I have only 1,000 customer ID. For each customer ID, I am creating one partition.
Sir,
Here,
I thought
this is. Huh?
For previous example. I
Previous
gave
example. No. Previous example. Yeah, previous example. Exactly. That is going to be your 1 crore example. Super. Okay, 1 crore. Okay, I have 1 crore customers. Then I end up with creating 1 crore partitions. Is it feasible? It is not feasible. It is not good idea at all. Then what we can do? This is kind of a list partition. I'm listing the partitions here. 1, 2, 3, 4, 5, 6, 7, 8. This is an example of a list partition. Got it? List partitions are best example is your January, February, March. This is every month you are creating a partition. This is your list partition. Okay. Clear what is the list partition? But it is not good in this example. Okay, then we are going to have one other example is a range partition. What is the range partition? Example, partition 1 can have the account number like customer from 1 to 10. This is the range 1 to 10 customers. Range of values, customer partition 2, 11 to 20 customers data I'm keeping here. See, this is how to create. This is the design technique. I don't think you will easily understand how to choose a partition, which type of a partitions to be used. It's all depends on how you read the data from the table. Are you based on the customer ID you're reading, or based on the monthly you're reading? Okay, that's again all the how you decide your indexes on which columns based on the columns used in the where class. Same thing here, what kind of a data you read your partitions and how you read your partitions will be differ. Here you have a list range. Example, Range is your example also. Range is here like customer number 1 to 10. I'm going to keep it in partition number 1, partition number 2. He is like this. And another one is a hash. Hash is, I don't know how it really works. Hash is, what is the meaning of hash? See, example, I can create an hash partition of 4. So it uses an internal algorithm. Okay, the randomly it distribute your volume into. There is a different purpose you create an hash partitions. It is not for read purpose. It is mainly used for the write purpose. But I don't think you'll understand what is an why. There is something called I don't know like so what happens if continuously you're writing a data for 1 to 10 customer. This partition become very busy. Yes, it become very busy because this area has become very hot. It become called hot area. We call them hot area. Why it is called hot area? Because you're continuously reading a data for customer 1 to 10. Suddenly you start processing something. We have a customer number 1 to 10. This become hot area. Hot areas are the one where you have a lot of DML operations. Okay, that's the reason these hot areas are very slow in nature because there is a lot of concurrency happens. A lot of write keep on happening on these hot areas. To avoid your hot areas, we distribute the data across the multiple. Example, 1 goes to the hash partition 1, 2 goes here, 3 goes here, 4 goes here. Again, 5 comes here, 6 comes here, 7 comes here. So it is kind of a round robin. It distributes your data across the multiple partitions to avoid your hot areas. Guys, this is very big topic, very big topic. I got this knowledge after working 20 years. I'm telling you, this is the truth. So you will not understand easily what is the meaning of unhot areas, what is the disadvantage of unhot areas, how to avoid it. Avoiding is your hash. How the hash value is generated, it has its own algorithms. Internally, it uses an algorithm called MD5. But I cannot tell all those things in one class, but try to understand different type of a partitions. If someone asks, you have a list partitions, you have a range partition, and you have an hash partition. But I don't know if you someone asked what is the use of an art partition, you caught. I don't think you can give this answer very easily. See, the performance tuning itself is 30 hours training. The database performance tuning itself is a 30-hour independent training you should go through if at all someone wanted to do an performance engineering. Believe it or not, that is my specialization area. I have published a book on this also. I am author of a book, How to Improvise the Performance of the Database. That is what I have worked in USA, JP Morgan. I was a performance engineer. For about 8 years, I worked on multiple applications to fine tune those real-time applications. That's why I have so much knowledge. That's the reason I published a book. But I'm giving only the high level of information, that is a 2% of the knowledge. What is the partitions? What is the different type of the partitions? But what pattern should be used? Again, it's a multiple decision we make on the board. What kind of a partition should be created and what column should be used? As of now, you do not understand it. Need not to understand also. All of you understood what is the use of the partition, at least the purpose of this class today. What is the partitions? When do you create a partitions? Please understand, whenever the table grows very big in nature, you cannot use as indexes because indexes cause you a double lookup. What is the meaning of a double lookup? Example, I wanted to find all January data. Your index itself is having 150 crores records, correct? Because this is the volume of the data we're talking. Then what happens? This is something called the context switch. We word user called context switch. What is that meaning? Word context, T-E-X-T-S-T-S-T. This is the word we call them a context switch. That is, switch happens between your index and the table. How many times the context switch will happen? Based on the number of entities or leaf. We call them a leaf or index keys. This is your index key and this is your leaves. Leaves is your values. How many leaves you have, so many times the context switch happens between your index and the table. That slow downs your, rather than reading the data, it's just doing like a lookup. Go here, find it, go here, find it, come here. Just keep on switching between your index and the table. This is called a context switch. Rather than fetching the data, it spent a lot of data time in doing the context switch. That slowed down your operations. That's the reason we are going to rearrange the data. See, example, whenever I read or insert any fresh data because of January, it is always going to fit it in this partition. So initially what we do is, hold on, I may have the script. I'll show you if at all I have a script. Let me unshare my screen. Hold on. I have that partition script, how we create a partitions. Just get an idea how we create the partitions. Okay. I don't know where it is. I kept. I had to look for. Okay. Whether in this laptop I have or not. Okay. Anyway, I'll Google it. That is the best way. Yeah. I don't know. I have that all the ready-made scripts, but anyway, I'll Google and show how we create the partitions table. Creating partition tables in Oracle for date using interval or range list. Okay. See, when you are creating an index or a table, we specify what is the partitions to be used. Okay. I don't know where we have script or not. Creating a range partition or creating list partitions or creating an external table. This partition table. Example they don't give. Yeah. This is your list. Okay, here look at here. This is how we specify what values it should contain. Okay, I'll copy paste. For your interest, don't worry, even nobody will ask you to create a partitions. This is how we create and see this is what we have done. What we have done, can you someone look at the data? It's easy to understand. I'm organizing the data based on the state. Example, I wanted to read US state. This is, we have a sales data, sales by region, department number and the state. Okay. So what we have done, we are listing, this is an example of a list partition. These kind of your state, whenever you have a record, it has a state as OR. It is going to be in the partition Northwest. Example, you have an Oklahoma or OK, it is going to be on the partition South Central. How many partitions we have? 1, 2, 3, 4, 5. All the data will be gathered in the 6 partitions. Example, I wanted to read Ghana data, GA. So what happens? It is going to Georgia, is not Ghana, Georgia or Florida. It is going to read from the single partitions. So this is how you create your partitions table. Whenever you run this, it will definitely create your table with a partition. Okay. You just go and run. It's a table created. Okay. How many partitions are created? You cannot see, but you have metadata, all tab, something partitions. You have talked about information schema in your this one and Snowflake. I have talked about information schema.
Only definition was covered. It was not covered in detail.
Yeah, I did not even miss out typing all table partitions. Exactly, I typed. Even after 6 years, I not forgot that metadata. See, it comes with an experience, guy. Don't worry. Okay, how many parties is table? Look at here. It is your table name and it has the partitions values. Okay, this is your partition value. Partition position 1, 2, 3. What is the value it will have? First partition will have a value OR and WA. This is your partition name. So whenever you insert the new data into this table with an OR1, where it is going to sit? It is going to sit in the partition 1. Example, I wanted to read all the data of state OR. What will happen? Washington WA. Okay, what will happen? It is going to read everything from the partition 1. It does not even look for other reasons, correct? Getting that point? Confusion, huh? Confusion.
Conclusion. No conclusion.
1 minute. Confusion, huh? Confusion. See what happens. See, instead of I am arranging the data, taken best example. Let's take, why not do rush into that? Okay. This is your, guys, please bear with me. If you're not following, please let me know. So we have a different state. We have an example. We have a different state. KA. Okay. HY, Gujarat. HY, Gujarat, Delhi. So customers can belongs to these states. Yes. Customer can belongs to any of these states. Example, I wanted to read all the customer data. Example, this is customer number 1, 2, 3, 4. Again, fifth customer it belongs to state number 5. Sixth customer is belongs to state number 5. So example, I wanted to find all the customers belongs to Hyderabad. I need to perform the full search. Correct. Otherwise, I need to create an index. Index will have the value 2, 6. This is how what happened when I create an index on the state. Ka, what is the K values will contain? K values will contain 1, 5. Whenever I say here state is equal to Ka, how index will work? How index will work? It goes to the index, find the row IDs, or your row IDs is not like this row IDs. I already told it is a 16-digit number. Using that, it goes and read from the table. Imagine your index itself is so big. Index is so big. What will happen? The performance will be reduced because it has to do multiple contact switches. For each value, it has to go to index, go to table, index, go to table, index, go to table. In these cases, what we are going to do, we are going to not helping with an index. What we are going to rearrange the data in such a manner that all the related data, such as your data like this, will be separated based on the partition. What is the partition I created? One state, Gujarat is, Karnataka is a one state, Hyderabad is one partition, Delhi is another partition. Tomorrow, new customer will join, customer number 10, it is going to be sit in Delhi partition. Okay. Example, tomorrow I am going to add a new customer belongs to Karnataka. What happened? This is your first partition. This is your second partition. Correct? And this is your third partition. Like that, how many partitions are made based on the distinct state do we have? Correct? It will be partitions are made. Example, tomorrow new customer is coming, customer number 20, Gujarat. Okay. I wanted to read all the data of the state Karnataka. Then what? I just read every data from the partition. This is an example of list partition. Clear? So whenever new data comes, it looks based on where it should go, which partition it should go. Already your table definition has that partition definition. Example, this is an example. K should come here. All the data goes to KA. Okay. Karnataka and Hyderabad, I wanted to keep it here. Okay. Madhya Pradesh and Delhi, I wanted to keep it here. Okay. Uttar Pradesh and I wanted to UT. I'm keeping here. So whenever you're inserting the data here, based on the state value, it is going to identify the partitions where it is goes and sits. So example, whenever I say state number Karnataka, it's read every data from the partition. This is called partition read. Index read, how we are doing an index read? We can also perform your index read. Got it? Clear? Not
Yes,
clear?
sir.
These questions. No questions. No questions. Good. Questions are not asked. I'm happy because you understood everything. Krisha, no questions. Nikki, no questions. Shilpa, no
Mm.
questions.
No,
Avinash,
sir,
no
understood.
questions. Okay. Good. So how partitions are, just you need to remember these things. We have a different type of list. You can go and check out the definition, but I already told list contains only one value, whereas range contains a range of values. Example, this is an example of range. List, this is example, not range, this is list, you are listing the values. Example, you can also use a range from 1 to 100, then you are going to use a range. Hash is something I don't prefer to talk, you get confusion. Okay, it's not like I don't know, but I definitely get confusion. I talk about the hash. I don't want to talk now. Okay, this is how your partitions are helping. This is our Snowflake is also maintains the partitions, but it is also maintains the micro partitions actually. Small of data that it contains, that is called micro partitions. We'll talk about it. Have you understood in high level what is the partitions when we use how partitions will help? See, example, I wanted to read all the Karnataka state data. I doesn't need to worry about how many partitions, other data in other partitions, data in other part. I worried about a small portion of the large table. The table could be of billions of records, but I'm worried. See, scanning is very easy. Look at the advantages for your database engine to find the record. Even though it doesn't have billions of records, it need not to worry because your data is isolated. January data is kept in one side. Sorry, Karnataka state data is kept in one. Gujarat is kept in other side. So it's small. The partition is helping the reading the small part of the large table. That is the definition. How it reads? It has a boundary. Inside the tables, this is your table. It has kept logically boundaries for each of your partition. So whenever you want to read a particular partitions, within this boundary, whatever the records it has going to be read everything. Got it? Got it? This is very helpful when you are reading the large amount of data or portion of the data from the larger table. Got it? Clear? Okay. Silence, I take answer, no questions. Okay, I cannot help. Anyway, so no questions. Many people left already. So any questions?